You think you know who you are, but neuroscience reveals something startling. Your sense of self is actually a controlled hallucination created by your brain. MIT researchers have discovered the hidden networks constructing your identity every second.
Its solution?
Understanding how your brain actually works? Stop for a moment and ask yourself this question. Who are you right now? You probably think you know the answer. You have a name, a history, a sense of being the same person who woke up this morning and went to bed last night. But modern neuroscience has uncovered something that might surprise you. Your brain is constantly constructing what researchers call the narrative self, essentially writing your autobiography in real time. This isn't speculation or philosophy. This is measurable brain activity happening in regions like the medial prefrontal cortex and posterior cingulate cortex. Scientists can literally watch your brain creating the story of you. But here's what researchers at institutions like MIT and Stanford have discovered. This story your brain tells isn't as solid as you think. The neuroscientist Anil Seth calls consciousness a controlled hallucination, and he means that quite literally. Your brain is constantly predicting what should be happening based on past experience, then checking those predictions against incoming sensory data. Think about this. You experience yourself as continuous, but every night you lose consciousness entirely during deep sleep. For hours, you essentially don't exist. Yet when you wake up, your brain seamlessly reconstructs the sense that you've been there the whole time. If your sense of self can disappear and reappear like that, what does that tell us about its nature? The implications run deeper than most people realize. If you're ready to discover what neuroscience actually reveals about the nature of human identity and why it matters for how you live your life, stay with me, because the research I'm about to share will change how you see yourself forever. Here's something that might disturb you. Most of your decisions happen before you make them. Benjamin Libet's famous experiments in the 1980s showed that brain activity indicating a decision occurs several hundred milliseconds before people report being aware of deciding. More recent research has extended this to several seconds for some types of decisions. This doesn't mean you have no free will, but it does mean the experience of being a conscious decision maker is more complex than it feels. Your brain is constantly processing information, making predictions, and initiating actions. The conscious experience of deciding often comes after the neural processes have already begun. Neuroscientist Michael Gazzaniga discovered something even more startling through his work with split-brain patients. When the brain's hemispheres can't communicate, he found that one hemisphere will literally confabulate explanations for actions initiated by the other hemisphere. He called this the brain's interpreter function, essentially a storytelling mechanism that creates coherent narratives even when it doesn't have all the information. This interpreter function isn't limited to split-brain patients. It's active in all of us, constantly creating explanations for our thoughts, feelings, and behaviors. Often these explanations feel completely true to us, but they're actually post hoc rationalizations. We think we know why we did something, but frequently we're just telling ourselves a plausible story. Consider how this plays out in daily life. You might think you chose that restaurant because the food is good, but research shows we're influenced by everything from the weather to what we had for breakfast to subtle environmental cues we never consciously notice. Your brain constructs a coherent reason, but the actual causes are far more complex and largely unconscious. This isn't a flaw in the system, it's a feature. Creating coherent narratives about our actions and experiences helps us learn, plan, and maintain social relationships. But recognizing this process for what it is can be profoundly liberating. While you've been thinking about consciousness, your brain has been running a hidden program that most people never learn about. Neuroscientists call it the default mode network, or DMN. And it might be the most important discovery in brain science of the past 2 decades. The DMN activates when you're not focused on a specific task, when you're daydreaming, remembering the past, or imagining the future. It includes brain regions like the medial prefrontal cortex, posterior cingulate cortex, and angular gyrus. Here's what's remarkable. This network is incredibly active, consuming about 20% of your brain's energy even when you think you're doing nothing. Research by Dr. Judson Brewer at Yale and others shown that an overactive DMN correlates with rumination, anxiety, and depression. When this network is constantly running, you get stuck in loops of self-referential thinking, worrying about the future, rehashing the past, comparing yourself to others. Sound familiar? But here's the fascinating part. Experienced meditators show decreased DMN activity during meditation and even at rest. Their brains literally operate differently instead of being caught in constant self-referential chatter. They demonstrate what researchers call present moment awareness. Brain imaging studies show that practices like mindfulness meditation actually change brain structure over time. Sarah Lazar at Harvard found increased cortical thickness in areas associated with attention and sensory processing in long-term meditators. Amishi Jha's research with military personnel showed that mindfulness training protected attention and working memory, even under extreme stress. This isn't about becoming a monk or spending hours on a meditation cushion. It's about understanding that your brain's default patterns aren't fixed. The constant mental chatter, the tendency to get lost in thoughts about past and future, the feeling of being at the mercy of your emotions. These are patterns that can be observed and modified through understanding and practice. Your brain evolved to keep you alive, not to make you happy. This fundamental mismatch between what your neural circuits were designed for and what you actually need in modern life explains why so many people feel anxious, dissatisfied, or restless. Even when their lives are objectively good, the threat detection system in your brain, centered around the amygdala, is constantly scanning for potential dangers. This system evolved when physical threats were common and immediate. But it doesn't distinguish well between a charging tiger and an awkward social interaction or a work deadline. Your brain treats them with similar levels of urgency. Dr. Rick Hansen, a neuropsychologist, describes the brain as having a negativity bias. It's like Velcro for negative experiences and Teflon for positive ones. This made sense evolutionarily. The ancestor who remembered where the dangerous predator lived was more likely to survive than the one who just remembered where the pretty flowers grew. Research in effective neuroscience shows that negative emotions tend to be processed faster and more intensely than positive ones. The brain regions involved in threat detection can hijack attention and flood the system with stress hormones in milliseconds. Meanwhile, positive experiences often need to be consciously savored to have lasting impact. This creates what researchers call the hedonic treadmill. You achieve a goal or acquire something you wanted, experience a brief boost in mood, then return to baseline. Your brain quickly adapts to positive changes, but remains vigilant for threats. It's a system designed for survival in harsh conditions, not for sustained well-being and relative safety. Understanding this isn't meant to be depressing, it's meant to be liberating. When you recognize that anxiety, dissatisfaction, and restlessness are often just your threat detection system doing its job in an environment it wasn't designed for, you can begin to work with these patterns rather than being controlled by them. The placebo effect isn't just about sugar pills making people feel better through wishful thinking. Modern neuroscience reveals that beliefs and expectations create measurable physical changes in the brain and body. This has profound implications for how we understand the relationship between mind and biology. Dr. Fabrizio Benedetti's research at the University of Turin has mapped the neural mechanisms of placebo responses. When patients expect pain relief, their brains actually release endorphins and activate the same pathways as opioid medications. Brain imaging shows increased activity in areas like the periaqueductal gray and rostral anterior, cingulate cortex regions involved in pain modulation. The effects go far beyond pain. Placebo responses have been documented for depression, Parkinson's disease, immune function, and even surgical outcomes. In some studies, patients who received sham surgery showed improvements similar to those who received actual procedures. This isn't psychology, it's measurable physiology. Dr. Elia Crum at Stanford has shown that even something as basic as metabolism can be influenced by beliefs. In one study, people who were told they were drinking an indulgent milkshake showed different hormonal responses than those told the same shake was healthy. Even though the actual nutritional content was identical, the implications are staggering. Your beliefs about stress, aging, your own capabilities, And what's possible for your health aren't just mental constructs, they're biological instructions. Research by Dr. Ellen Langer showed that when elderly men were immersed in an environment from their youth and encouraged to act as they did decades earlier, they showed measurable improvements in vision, hearing, memory, and physical strength. This doesn't mean positive thinking cures everything, or that illness is simply a matter of wrong beliefs. But it does mean the relationship between psychology and physiology is far more intimate than most people realize. Your brain is constantly translating your interpretations of reality into biological responses. Until relatively recently, scientists believed that adult brains were essentially fixed. You got the brain you were born with, maybe lost some neurons over time, and that was it. This view has been completely overturned by discoveries in neuroplasticity, the brain's ability to reorganize itself throughout life. Dr. Michael Merzenich, often called the father of neuroplasticity, has shown that the brain remains malleable well into old age. Focused practice can literally rewire neural circuits. London taxi drivers, who must memorize the city's complex street layout, show enlarged hippocampi, the brain region involved in spatial memory. The enlargement correlates with years of experience. Even more remarkably, this plasticity extends to fundamental brain functions. Alvaro Pasqualione's research showed that people born blind develop enhanced auditory processing in visual cortex areas. Musicians show enlarged motor cortex regions controlling finger movements. These aren't just adaptations. They represent fundamental rewiring of brain circuits. The key insight is that the brain changes based on what you repeatedly do, think, and pay attention to. Every time you practice a skill, rehearse a thought pattern, or focus your attention in a particular way, you're strengthening those neural pathways while others weaken through disuse. Dr. Jeffrey Schwartz demonstrated this principle clinically with obsessive-compulsive disorder patients. By teaching them to recognize OCD thoughts as brain glitches rather than accurate information, and to redirect attention to other activities, patients literally rewired the circuits involved in the disorder. Brain scans showed measurable changes in the cauda nucleus and other areas. This has revolutionary implications for how we think about personality, habits, emotional patterns, and even fundamental aspects of how we experience reality. The patterns that feel most you, the way you typically react to stress, your automatic thought patterns, your emotional tendencies. These can all be gradually modified through sustained, intentional practice. Now that you understand what neuroscience actually reveals about consciousness, identity, and the brain's incredible plasticity, the question becomes, what do you do with this knowledge? First, recognize that most of your mental suffering comes from taking the brain's storytelling function too seriously. Your constant internal narrative, the voice that comments on everything and creates elaborate scenarios about the past and future, is a biological process, not the voice of ultimate truth. Learning to observe this chatter without being consumed by it is perhaps the most valuable skill you can develop. Second, understand that your emotional reactions, while real and valid, are largely automatic responses from threat detection systems that evolved for very different environments. You don't have to be controlled by every anxious thought or negative emotion. These are patterns that can be observed and gradually modified. Third, take advantage of neuroplasticity. Your brain will change regardless. The question is whether it changes intentionally or by default. Regular practices like meditation, focused learning, physical exercise, and conscious attention to positive experiences can literally reshape your neural circuits over time. The research shows that small, consistent practices often have more impact than dramatic but unsustained efforts. 10 minutes of daily mindfulness meditation has measurable effects on brain structure within 8 weeks. Regular gratitude practices strengthen positive memory networks. Even simple breathing exercises can retrain the autonomic nervous system's stress responses. Remember to like this video if you found these scientific insights valuable, and subscribe for more evidence-based explorations of consciousness and human potential. The goal isn't to become a different person, but to understand the person you already are from a scientific perspective. Your brain is an incredibly sophisticated information processing system that evolved to help you survive and thrive. By understanding how it actually works, rather than how it feels like it works, you gain the power to work with your neurobiology rather than against it. This isn't about transcending your humanity, it's about embracing it with greater wisdom and intentionality. The most profound discovery of modern neuroscience might be this: you are not a fixed entity navigating a predetermined reality. You are an ongoing process, constantly creating both your sense of self and your experience of the world through the very act of being conscious. And that process can be understood, appreciated, and gently guided toward greater well-being and insight.